Welcome to this video about NumPy, a powerful numerical computing library in Python. NumPy provides support for multidimensional arrays and mathematical functions, making it a popular choice for scientific computing, data analysis, and machine learning as well. In this video, we will explore some of the key features of NumPy and see how it's used in real-life examples and industries. So here are the agenda for the video. NumPy is a Python library that provides support for large multidimensional arrays and matrices, as well as a collection of high-level mathematical functions to operate on these arrays. It was created in 2005 by Travis Oliphant, who was looking for a better way to work with large data sets in Python. Since then, NumPy has become a fundamental library for scientific computing with Python and has been widely adopted in academic, industry, and research. One of the primary reasons for the popularity of NumPy is its efficient implementation of arrays. NumPy arrays are stored in contiguous blocks of memory, making them more efficient than traditional NumPython list for numerical operations. This makes it possible to perform complex mathematical operations on large data sets with relative ease. In addition to arrays, NumPy also provides a range of mathematical functions and algorithms for linear algebra, Fourier analysis, and much more. These functions are optimized for use with NumPy arrays and can be used to perform complex calculations with ease. Let's dive into some of interactive code examples to see how NumPy works in practice. We will start by importing the NumPy library and creating a simple array. So import NumPy as np, define my array as np.array and just print it. The output looks like the array of 1, 2, 3, 4. We can perform mathematical operations on array such as adding, subtracting, multiplying and dividing as given in the second example. We can also perform element-wise operations on arrays using NumPy's mathematical functions like np.exp. It gives the exponential of each and every element in the array. NumPy also provides many other useful functions such as sorting the array using np.sort, as such as sorting the array as well as the reshaping the array, np.reshape. NumPy is used in many real-life examples such as analyzing climate data to detect trends and patterns, processing images and videos in computer vision applications, analyzing financial data to make investment decisions, simulating physical systems in physics and engineering, building recommendations system in the machine learning. Let's take a closer look at how NumPy is used in analyzing climate data to detect trends and patterns, such as the climate scientists use a variety of data sources, including satellite observations, weather station data, and historical records, to understand how the Earth's climate is changing over the time. One of the key challenges in analyzing this data is detecting trends and patterns in the midst of noisy and complex data. This is where the NumPy comes in picture. With its support for multidimensional arrays and mathematical functions, NumPy is natural fit for working with large and complex dataset like climate data. Climate scientists can use NumPy to perform a wide range of operations such as filtering the data to remove noise and anomalies, calculating statistical measures like mean, median, and standard deviation, performing time series analysis to detect long-term trends and seasonal patterns, visualizing the data in plots and charts to better understand patterns and relations. Let's take a specific example of how NumPy can be used in climate data analysis. Imagine we have a data set of monthly temperature reading from a weather station over several decades. We can load this data into a NumPy array and use the NumPy function to analyze it. Here is the code given. We have to first import a NumPy, and for visualization I will use matplotlib, which we'll cover in the few next videos. First of all, to load the temperature data from the file, we need to have np.loadtxt. We need to calculate the monthly average temperature over the time. So we need to just write np.mean to calculate the monthly average temperature. For the annually average temperature, we have also a function np.mean. To plot annual average temperature over the time, we have used matplotlib here. In this example, we first load the temperature data from the file using numpy's loadText function. We then use numpy's mean function to calculate the monthly as well as the annual average temperatures over the time. Finally, we use the matplotlib library to create a plot of annual average temperature over time. This is just one example of how NumPy can be used in climate data analysis. With its powerful array manipulation and mathematical functions, NumPy is a valuable tool for scientists working to understand our planet's changing climate. Use of NumPy in industry. NumPy is widely used in industries such as in finance. NumPy is used for quantitative analysis, risk management, and algorithmic trading in the finance industry. Aerospace, NumPy is used for simulating physical systems and analyzing the data in the aerospace industry. For medical research, NumPy is used for analyzing and processing medical data in research as well as the diagnosis. For gaming also, NumPy is used for physics simulations and game development in the gaming industry. Let's dive deeper into how NumPy is used in finance for quantitative analysis, risk management, and algorithmic trading. In the financial industry, data analysis is critical for making informed investment decisions. With vast amount of financial data available, analysts need tools that can handle large data sets and perform complex calculations quickly and accurately. This is where NumPy comes in picture. NumPy's support for multidimensional array and mathematical functions make it an ideal tool for performing quantitative analysis in finance. Here are few examples of how NumPy used in finance. Financial modeling. NumPy can be used to create a mathematical model that simulate financial scenarios and predict the future outcomes. For example, NumPy can be used to create Monte Carlo simulations, which are commonly used in finance to model the risk and return of investments. Portfolio optimization. NumPy can be used to optimize investment portfolios by calculating the expected returns and risk of different investment strategies. This allows analysts to create portfolios that maximize the returns while minimizing the risk. Algorithmic trading. NumPy is a key tool in algorithmic trading, which involves using mathematical models and computer algorithms to automate trading decisions. NumPy can be used to perform statistical analysis, calculate moving averages, and detect trends in financial data, all of which are important for making informed trading decisions. Let's look at the specific example of how NumPy can be used in finance. Imagine we have a data set of stock prices for a company over a several years. We can load this data into NumPy array and use the NumPy functions to perform the analysis. So in this example, we'll first load the stock price data from a file using NumPy's loadTxt function. We then use NumPy's different functions to calculate basically the daily returns, which are percentage changes in prices from one day to the next. We then use NumPy's mean and steady functions to calculate the mean daily return and risk adjustment return that compares the mean return to the standard deviation of returns. This is just one example of how NumPy can be used in finance. With its powerful array manipulation and mathematical functions, NumPy is a valuable tool for analysts as well as the traders in the finance industry. Last but not the least, I want to conclude this session with the following points. NumPy is a powerful library for working with arrays as well as the matrices in Python language. It is widely used in many fields, including data science, machine learning, and engineering. With NumPy, you can perform complex mathematical operations on large data sets with very ease. NumPy is easy to use and provides a wide range of capabilities for numerical computing. Overall, NumPy is an essential tool for anyone working with data in Python. Thank you so much.